Hi students, this is lesson 2.5 and the learning goal for this lesson is I can find any trigonometric ratio of a right triangle given an angle using the unit circle. So we will definitely be embracing the radians and some fractions, some reference angles, and coterminal angles. Criteria for success. So we have several steps with these problems. We're going to draw the angle within the unit circle. And if necessary, we will find the coterminal angle. We are going to identify the quadrant that the angle is in. We will identify the SIGN, positive or negative, of the function in the given quadrant. We will calculate the reference angle. We will draw the special right triangle. And then we're going to evaluate the trig function and apply the appropriate sign. Okay, so each slide has these steps on there. We're going to first go over something. This is in page 11 of your packet, and you may have already done this with me. If so, you can just fast forward ahead here. So this is our unit circle, and we have our, X right here. Our Y is our height. Those are the lengths of the triangle. We have our, of course, our angle measure is theta right here. Okay. So it says point XY, that's right here, is given by some angle theta in the first quadrant of the unit circle. Now, please notice this point is this far out on the x-axis, a distance of x. That's why we have x here. And then it's also a height, of course, of y, and that's why we have that y. So x comma y. What is the length of the hypotenuse? So this would have to be 1 because we're talking about a unit circle. Now the next thing is saying what is the ratio for sine in terms of y? So we would say here sine of theta would be the opposite, that's this guy, y, over 1, or just y. What is the ratio for cosine in terms of x? So we do the same thing. Cosine of theta is going to be the adjacent, which is this x value over 1, which is x. So in this case, you're going to notice in the unit circle that when we have an ordered pair, it's actually going to correspond to cosine of the angle and sine of the angle. And we'll go around the whole unit circle that way. What is tangent in terms of x and y? So tangent of theta is opposite over adjacent. That would be y over x. Okay, now it's asking, hey, think about what we did in B and C and D. This is D. What is tangent in terms of theta? Well, let's think. Tangent of theta is the same as y. And don't we know that y is the same as sine of x? So we can just replace, or sine of theta rather, replace the y with sine of theta. In a similar way, we can see that x is the same as cosine of theta. And I can go ahead and replace x, so I'm replacing these with their corresponding equivalent pieces. So sine of theta over cosine of theta is equal to tangent of theta. So think about that. If you know this ordered pair, then you could actually calculate tangent. So if we take, for instance, this is pi over 2. Okay, remember that's 1 whole pi. This is 2 pi, 3/2 pi. If I wanted to find sine of pi over 2, I see that I have this point. This is the point x comma y. Sine corresponds, sine of theta, in this case pi over 2, corresponds to the y coordinate. So this is actually 1. And if I wanted cosine of the same angle, that corresponds to the x coordinate, or 0. If I wanted tangent of that same angle, well then we would need to take the y and put it over the x, which is undefined. If you were to go ahead and graph the tangent function, you would see there are several vertical asymptotes, and that is because Whenever I divide by 0, I get an undefined value. So these are going to correspond with your sine, cosine, and tangent graphs, but we're going to learn how to use this unit circle and the special right triangles to get the outputs. Okay, so the first one we're going to do is we're going to evaluate the cosine of 3/4 pi. So I am looking to find what is the cosine of 3/4 pi. Now, certainly you could plug this into your calculator. We're not going to do that just yet. We can do that to check, but we do want an exact answer, and we want to make sure we understand what is actually happening. So the first step here is if we need to find a coterminal angle, we're going to do that. Now, usually you'd like to be an angle measure within one rotation here. So between 0 and 2 pi, let's say, which 3/4 is. So we're okay to start going here. All right, so again, you can label some of these pieces, and it's 3/4. Remember, this is 4/4 pi. So 3/4 is going to be right about here. And that is my angle. This is 3/4 pi. Okay, so one of these is asking this, so we already drew the angle. Now we have to identify what quadrant is this angle in. And this angle is in second quadrant. Okay, second quadrant. Okay, now identify the SIGN, positive or negative sign of the function. So let's think, in the second quadrant, we have negative, comma, positive. All the x values are negative, all the y values are positive. So in this case, the sign of the cosine of this angle is going to be negative. So cosine of 3/4 pi will be negative. So it's a negative something. We don't know the something yet. That's okay. All right. Now, we're going to, oh man, I have these two things reversed. I'll fix it for the slides. But, oh no, actually this is perfect. Okay, never mind. So for this one, we want to calculate the reference angle, which in this case is this piece right here. So the reference angle is going to be pi, take away 3/4 pi, which is just 1/4 pi. Okay, 1/4 pi. This is the reference angle. Now we're going to draw a special right triangle. This is where those little special right triangles are going to come into play. So this is pi over 4. This is also going to be pi over 4. Okay, and remember this 90 degrees is really pi over 2. So altogether, we'd have 180 degrees, which is 1 pi. Okay, now I am going to just redraw that triangle a little bit bigger, and you don't need to redraw this a bunch of times, but it's just a little easier to see, hopefully. When we have our special right triangle, we know, just as a little note here, pi over 4 is the same as 45 degrees. That's our 45, 45, 90. Well, we know the hypotenuse is 1, and both of these congruent sides are radical 2 over 2. Okay, now we want to find the cosine of this angle. Okay, cosine of this angle. And you're saying, hey, Mrs. Wojcik, we actually want the cosine of 3/4 pi. So this is the beauty of this, is we're going to actually be able to find the same x coordinate using this triangle. So if you know the two little special right triangles, you are going to be really able to just hammer out all these problems. You're going to really be able to understand how to create that unit circle. So from here, we would say that the cosine of this angle is going to be the adjacent over the hypotenuse. Okay, adjacent over the hypotenuse. So here's what I'm going to write now. This is the final thing. The cosine of 3/4 pi equals, we said it was negative because look what quadrant I'm in. And the answer is negative radical 2 over 2. So that is my final answer. Okay. So we're going to do a bunch more of these, and you can certainly check this on your calculator if you'd like. When you do it, you'll get a decimal. So you just want to make sure that if you take the negative square root of 2 and divide by 2, you get the same exact decimal. Okay, and something I didn't do here is draw my unit circle. So kind of didn't follow my own directions. So we're just going to pretend like this is the unit circle here. Okay, that's kind of terrible looking, but we'll do better on the next one. All right, so we evaluated the function and we got the appropriate sign, and here we are done. Okay, so this is going to be the sine of 11/6 pi. So let's go ahead and draw. Let me actually draw my unit circle this time. Okay, not awesome, not horrible. And we are going to go ahead and draw our angle. So 11/6 pi. So let's think about this. This is 1 pi, 2 pi. This would be 3/2 pi. So if we're talking about 6, this is actually 12/6 pi. 12/6 pi is 2 pi. This would be 6/6 pi, which is the same as 1 pi. So if this is 6, this is going to have to be 9/6 pi, and we need to go to 11. So probably 10, 11. We're going to say right about there. Okay, so this is 11/6 pi. This is the angle we're looking at. So this to right here. Okay, we didn't need to find a coterminal angle because, again, we're within that one rotation, so no problem there. Identify the quadrant. So we are in quadrant 4. And the sign in quadrant 4, let's think about this. The x's are all positive. The y's are all negative. And since sine corresponds to the y, it's going to be negative. Okay, quadrant 4, the sine of 11/6 pi will be negative. Okay. Calculate the reference angle. So now we need to look for that reference angle. So we're looking right in here. Now, if this is at 11/6 and this is 12/6, how much space is this? It's just 1/6. So the reference angle is pi over 6. Now, just as a little reminder, pi over 6, this is a little one we're going to work with, is the same as 30 degrees. So already we're thinking, this is a 30, 60, 90. We're going to go ahead and draw the right triangle. Okay. Inside of here, let me see. I'm going to make this a little bigger so I can fit it. This is going to be pi over 6. This will have to be pi over 3. So this is a 30, 60, 90. Okay. I'm going to redraw my triangle here just because, again, it's a little squished. Pi over 6, pi over 3, and a right angle. And this is the angle we are looking at. Okay, this is our reference angle. Now we want the sine of that angle. So let's think about this. The smallest side has that 1/2. The hypotenuse is the biggest, that has 1, and then radical 3 over 2 is the middle side. Sine is always the opposite over the hypotenuse, which is 1/2 divided by 1. So when I evaluate this, don't forget, we need a negative. That's very important. It's going to be negative, and now what's the something? Oh, well, we said it's 1/2 divided by 1, which is just 1/2. So this is now evaluated. Okay, tangent. Tangent of 4/3 pi. Okay, again, I'm going to draw my unit circle in here. Oh man, that's horrible. Look at that. Okay, so 4/3 pi. Again, I don't need to worry about any coterminal angle. This is well within one rotation. This would be 3/3 pi if we're thinking in thirds. Okay, so when we're drawing this, this is 3/3. this would be 4/3. And think this is 5/3, this is 6/3. So just try to think about, you're splitting that half circle into 3 equal parts. So this is our angle, 4/3 pi. Okay. Identify the quadrant the angle is in. So the angle is in quadrant 3. Now let's remember quadrant 3 is negative x's and negative y's. So we're going to say tangent is positive in quadrant 3. So that's why we're finding out, well, which quadrant are we actually in? Because notice we're only looking at 2 triangles, no matter all the different angles we're trying to find the ratios for. So we want to find out the sign, so we know for sure this answer is going to be positive something. Okay, we don't know the something yet, that's okay. Reference angle. So we need just this little bit in here. So if this is 4/3, how much past 3/3 did I go? Just 1/3. So we would say the reference angle is pi over 3, or 1/3 pi. And now we draw our right triangle. Now this point should be right on the circle there. Okay. Again, I feel like I'm too squished there. So I'm going to just expand that out here. So the reference angle we said is pi over 3. That still looks terrible. Okay, pi over 3. And so this has to be pi over 6. Now don't forget, pi over 3 is the same as 60 degrees. So the radian and degree measured, those are equivalent. So again, the tiniest angle gets the tiniest side, 1/2. The hypotenuse is 1, we're dealing in the unit circle here, and then the middle side is radical 3 over 2. Okay, so let's think, we want tangent. Now remember in the first slide, we were talking about how tangent is the same as the y over the x, and we could also think opposite over adjacent. So if we're looking at this angle here, that's the same as right here. We want to do, for tangent of pi over 3, we're doing the opposite over the adjacent. So we're going to say this is radical 3 over 2 over 1/2. Now dividing by 1/2 is the same as multiplying by 2. And the 2's are actually going to cancel. So when all is said and done, your answer should be a positive radical 3. Okay, just a couple more here, some little unique examples. Cosine of 4 pi. Okay, so for 4 pi, what we could do is find that coterminal angle. So coterminal angle. And when I do that, remember you are adding or subtracting a full rotation. So I'm going to take away a full rotation. That's 2 pi. And I mean, I guess you could take away another full rotation and just be at 0. So really, there's nothing to draw here. We're right here at 1, 0. Okay, so we're in no quadrant, okay? No quadrant. Identify the sign, S-I-G-N. So again, if we're thinking cosine, well, of course, this is on the positive x-axis. That's positive. There is no reference angle. There's no triangle we're going to draw. We're just going to evaluate. This is the same as the x-coordinate, which is 1, and that's it. So sometimes you're going to get some really nice, quick values on that unit circle, and you'll be able to go ahead and just give those values. Another thing that could happen is you could have a negative. So this is negative 5/3 pi. This is still an angle. This still lives on that unit circle. So let's think about negative 5/3. I think what I'd like to do is find a coterminal angle with a positive value. So coterminal angle, I'm going to take negative 5/3 pi, and I'm going to add a full revolution, which is 6/3 pi, the same as 2 pi. That is 1/3 pi. So this coterminal angle is right here at pi over 3. Okay. Now, if we want to go ahead and, if you were to go in the negative direction, this would be negative 3/3, 4/3, 5/3. Of course, we'd be at the exact same spot. That's the beauty of the coterminal angle, is that this angle, if I come in from this direction, hits exactly that same terminal side. So all we have to do is add or subtract one full revolution. Okay, now let's think about reference angles. So the reference angle for this is actually that same exact angle measure, right? Just that pi over 3. And then we go ahead and we draw in that right triangle. So again, I get too squished in there. We have a right angle. This is our reference angle, which is pi over 3. And then we know special right triangles, this other guy has to be pi over 6. The smallest side is across from 1/6 pi. The middle side is across from pi thirds. And of course, again, we're in the unit circle, so the hypotenuse is 1. Okay, evaluate the trig function. Oh, and we did not look at the sine or the quadrant. Oh my goodness. So we are in quadrant 1, and sine is positive in quadrant 1. This is positive, positive here. Okay, so the special angle we're looking at is this guy, which is right here. So I'm just translating it over. And we want the sine, which is the opposite over the hypotenuse. So in this case, it is just going to be radical 3 over 2 divided by 1. And since we know it's positive, this is our final answer. Okay, you should definitely be in the pit. I want you to take it slow, and we're going to definitely practice this in class, but try to sit with this a little bit, and then we're going to take all the questions. So make sure you write down whatever question